Welcome back to the workshop. We want to continue taking a look at section 1.2, a matching problem. And we're continuing on in this example where we're pairing up 7 brides with 7 brothers. And what we want to do next is we want to consider a specific pairing, a specific matching. And in this matching, right, we already have that these 7 brides and 7 brothers have these connections between them. They get along. Not everyone gets along with everyone else. And we want to look at this pairing and say, all right, those that we've paired together, do they actually get along? Is this a pairing that would work? So let's take a look at this pairing and see what we have. So this is the nice visual representation that we created from our list. And we want to take a look at this pairing. So if we pair Millie with Adam, Dorcas with Frank, Alice with Caleb, Sarah with Ben, Liz with Ephraim, Ruth with Gideon, and Martha with Dan, we want to decide if this is a good pairing or not. So this is, again, this visual representation. Do we absolutely have to have that visual representation? No, we're going to find that our questions have good answers based on these visual representations a little bit later in the course. Again, right, these nice pictures, dots with lines, graphs, things that we will take a look at a little bit later. So do they get along with one another? So Millie and Adam, do they get along? Millie and Adam, yes, they do. So that's a thumbs up there. Yes, do Dorcas and Frank get along together? Dorcas is connected to Frank, so yes, they get along. We could just go up a little bit further to that list to see if they get along as well. Alice and Caleb, do they get along? Alice and Caleb, yes, hey, everything is looking great so far. Easy peasy, right? Yes. Sarah and Ben, is Sarah paired with Ben? Oh no, that one doesn't work. Sarah and Ben do not get along. Sarah and Ben do not get along. Let's see, Liza and Ephraim. Liza and Ephraim, yep, we're good to go there. So yes. Ruth and Gideon, notice that the list that I came up with, the pairing is just this list and this list. So Ruth and Gideon do not get along, and Martha and Dan do. So Ruth and Gideon do not, but Martha and Dan do. So 2 pairings where they do not get along. So that's not ideal for us. We want to get as many pairings as possible where they're happy. So maybe if this is the best we can do, okay, but is it the best we can do? And you might be able to figure that out on your own. Is there a better pairing? And yes, there actually happens to be, but it's not always obvious. Especially when you get more items involved, right? 20 brides for 20 brothers. 20 brothers, man, that's a lot. Anyway, well, 7 is a lot too. But this is the idea, right? I can pair them and see if it's any good or not based on what I was given. So that could be a process. Consider all possible pairings and find out which one is best. So I'm going to skip over this for just a moment, but one way to identify the best matching would be to, again, consider all possible matchings. Look at all ways that we could pair up the 7 brides with the 7 brothers. So if we were to pair them all up and then evaluate each one of them, we would essentially or 2 questions that would follow up with this would be, how much work is it going to take to do that? It's 7 people. That's a lot of people. How right, or 14 people that I'm pairing, 7 pairings. And then how can we generate all possible matchings just so that there are none that have been missed? Right? Again, how do I know I've done them all? So these are 2 questions that come up, and these, right, not only is this problem itself here a combinatorial problem, but the questions that result are also combinatorial problems. How much work is it is another combinatorial problem. And how can we generate all possible matchings so that we know none have been missed is another combinatorial problem. Okay, so we want to consider these things. And one of the things that's really going to help us is understanding a way to represent the matchings or the pairings. So what we can do is if we fix this first list of the brides, if we fix this first list, just leave it, and we only rearrange the brothers, then the only thing that would be necessary for us to identify a specific matching is to list the names of the brothers. So I can identify this particular matching by leaving this row fixed, or this column fixed, and just listing the names of the brothers. So this particular matching is given by this list of brothers' names. So I can just rearrange the brothers' names, and the first person is always paired with Millie, the second person is always paired with Dorcas, second brother is always paired with Alice, and so on. So then we only have to have one list of names at any given time. So that's one way. So then the question doesn't necessarily become how many ways are there to pair them. The question now is simplified to how many different ways are there that I can order these 7 brothers' names, which is a much easier question to answer. So that makes the problem a little bit more simple. And that's exactly what we're going to take a look at in the next video. How do we count how many ways there are to order things? So I will see you guys back in the workshop very shortly for a discussion on the counting principle and permutations. See you in a minute.